Hi, I'm Lindsay from Stats Medic, and in this lesson, we are learning about what is a confidence interval. So we are starting a new unit today, and this unit is all about confidence intervals, and more specifically, confidence intervals for proportions. So we have 4 learning targets. We're going to start by identifying an appropriate point estimator and then calculating the value of a point estimate. We're going to interpret a confidence interval in context, determine a point estimate and margin of error from a confidence interval, and then also use a confidence interval to make a decision about the value of a parameter. So our context today, we're talking about this jar that I have in my classroom. So in this jar, I have red beads and black beads, East Kentwood colors. And when a student does something great, they get to pick a bead from the jar. Now, if the bead is red, they get a piece of candy. If it is not red, so if it's black, then they do not get a piece of candy. The question is, what my students want to know is, well, what are the chances that a student chooses a red bead? Or in other words, what proportion of the beads in the jar are red? So what I do is I walk around and I give each group a sample of beads. And then from that, they're going to create a confidence interval to estimate the true proportion of red beads. So they're going to get 20 beads, and then it's up to them, based on those 20 beads, to make a guess or an approximation at what they think the true proportion is. Now, to make this a little bit more competitive, what I tell my students is whichever group has the smallest interval that still captures the true proportion of red beads in the jar, they win a prize. So they get their 20 beads, they figure out, okay, how many of them are red, and then it's up to them to decide from that proportion, how far out do they want to go. They could say there are between 0 and 100% of red beads in the jar. Well, yeah, of course, but then they're not going to win because they weren't narrow enough in their guess. So what we're going to do is I'm going to give you a sample of 20 beads. And really, I'm just going to tell you how many of them were red. So if I give you 20 beads, 7 of those beads were red. So what I'd like you to do is to work through this entire page. Again, thinking about, okay, if you were doing this in class, what you would want is you use that 7 out of 20 beads to create an interval, and you want that interval to be as tight as possible while still containing the true proportion that are red beads. So take some time and work through this, and then hit play when you're done, and we'll go through the page. All right, so let's add some things into the margins here. So if you could get out a different color pen or pencil, I'm going to start here number 1 with our proportion red. Now I told you there were 7 out of 20 in your sample, so that should be a proportion of 0.35 or 35% red. This is your point estimate. And we also have a symbol for this point estimate already. This is a sample proportion, which makes this a p hat. So if you could go ahead and add a p hat there. So in this case, our point estimate for the true proportion of red beads is p hat equals 0.35. When we're talking about a point estimate, we're talking about, okay, well, you have one sample, and from that sample, you have one statistic. That statistic is our estimate for the truth at this point in time. So we call that our point estimate. Then in number 2, we're asked about a population, parameter, sample, and statistic. We've done that many times now. Now, what was probably a little bit tricky here was the parameter, because for the statistic, well, we have that. Our statistic is 0.35. Again, here you'll notice on mine, I didn't put a symbol, so I'd like you to add that in if you didn't. This is a p hat. And additionally, I'm going to point out again that this is a point estimate. So your statistic and your point estimate are sort of interchangeable in this case, or the way we phrase that. Now my parameter, remember that's the true proportion. Well, I don't know what the true proportion is. So maybe you left that blank, or maybe you put a question mark. What we're going to put there going forward instead, since we don't know the true proportion, that's the whole point of this, we're going to define that variable. So if my statistic is a p hat, that means my parameter must be p. And what I'm going to do is I'm going to label this as the true proportion red beads. Technically red beads in the jar, but I'm running out of room there. So we start with our statistic. It's a p hat. Okay, that means my parameter must be p, and I'm just going to call that the true proportion of whatever the thing is that we're dealing with. All right, now in number 3, we're changing from our point estimate into an interval. So we have 35%, or 0.35 is our point estimate from our sample. So the question is, how far from that do you want to go? So this is totally up to you. You do not need to have what I have. This was just kind of the way I thought through it. I thought like, well, if I had 2 more red beads or 2 less red beads, that'd be a 10% swing in either direction. So I said I would do plus or minus 0.10 or plus or minus 10%. Again, totally up to you. Doesn't matter. This was just for you to decide what you thought a good range was to be. So this number that we're adding and subtracting, or that we're using to go out from our point estimate, that is called a margin of error. All right, so then we use our point estimate and margin of error to create an interval. So I have on mine for number 4, I've got that 0.35. You should have that as well. But then you're going to add and subtract whatever you decided as your margin of error. So I did 10%, which gave me an interval of 0.25 to 0.45. Next to that, I'd like you to label then. So the way we came up with that is it was our point estimate plus or minus the margin of error. So when we're creating a confidence interval, that's what we're using. We have our point estimate, which came from a statistic, and then the margin of error, which is sort of like our wiggle room on both sides. Number 5, how confident do you feel that your interval captures the true proportion? I feel pretty good about mine. 25 to 45% seems pretty reasonable. So I said maybe 90% confident. Again, that is totally up to you. So what I want to do next to this in the space I have is I'm going to interpret that confidence interval using that percentage. So I'm going to put it in quotes so I remember it's an interpretation. And the way we're going to phrase this interpretation of a confidence interval is I'm going to say we are blank percent confident that the interval from blank to blank captures the true proportion of red beads in the jar. So because we have different values, I'm going to fill mine in green. So I'm going to say we are, I would say 90% confident that the interval from 0.25 to 0.45 captures the true proportion of red beads in the jar. So this is an interpretation of a confidence interval. All right, and then in number 6, we're given an example of one of the other groups in the confidence interval they made was from 0.27 to 0.33. So what was their point estimate? Meaning, what was their starting point? Well, in this case, their starting point is going to be right in the middle of that interval. So remember, we started out up above with point estimate plus or minus margin of error. So to figure out what the point estimate is, we can work backwards and think, okay, it had to be right in the middle. So what I'm going to do to the side here is I'm going to label this as for interval. And I'm just going to call it like A to B. The point estimate Well, we need to figure out what the middle would be. Well, you could really just find the average of the two endpoints. So I'm going to write this as a plus b divided by 2. So in this case, that is 0.30. And then the margin of error, well, the margin of error is we're taking the width of the whole interval, and I'm going to cut it in half because remember, it was coming plus or minus from the center. A lot of students will accidentally forget to cut it in half, or instead they just give the width of the whole interval. So make sure you are splitting that. So on the other side, over here, I'm going to put margin of error equals. You could do it a few different ways. I like to do the width, so b minus a, and then divide it by 2. All right. And then the last question, one group claims that the true proportion of red beads is 0.25. Does your interval support or deny that claim? So it depends on what your interval is. Now with my interval going from 0.25 to 0.45, well, my interval contains 0.25. So I would say, yes, it does support that claim. So what I'd like to add in below this is that confidence intervals contain all plausible values. So in this case, if a group is claiming 0.25 and 0.25 is in your interval, well then yes, our interval supports that because it's saying 0.25 is plausible. If it is not in your interval, then we'd say your interval denies that claim because 0.25 is not a plausible value. All right, so let's go through our important ideas. We had quite a bit. So what I'm going to start out with here is just our idea about what is a point estimate. And my point estimate is a statistic that provides a reasonable estimate about the population parameter. So just like we did when we were learning about statistics and parameters, well, here the point estimate is giving us a guess at what our parameter is. So like p hat, for example, gives us a guess at what p would be. And then X bar gives us a guess at what mu, the true mean, would be. And then next, I'm going to do learning targets 2 and 3 together because we were asked about point estimate and margin of error, or told that we had to find that. So what I'm going to do here is I'm going to say for interval A to B, the point estimate would be A plus B divided by 2, or in other words, the middle. And then your margin of error, we want to find the width of the interval and then cut that in half. So I do B minus A divided by 2. Now we can also do an interpretation for this. So again, in quotes, what I'm going to put here is I'm going to say we are blank % confident that the interval from, in this case, my interval is from A to B. We say captures the true, and then I'm going to put parameter in context. In today's lesson, we were just looking at proportions, but in the future, we'll also be looking at means or difference in proportions. Now, one thing to note, that percentage about how confident we are, we'll be learning more about that in tomorrow's lesson, and really how do you pick a confidence level. All right, and then the last part was about making decisions based on your confidence interval. And so the big idea here is that confidence intervals contain all plausible values. So when you're making a decision about a claim based on a confidence interval, you have to just stop and think about, okay, these are my plausible values, the values that are inside this interval. Do they support or do they deny the claim that's being made? And it's on sort of a case-by-case basis. All right, if you could please try the check your understanding problem. It should go pretty quickly, and then hit play when you're done and we'll go through our answers. Okay, so in this check your understanding, we're talking about adults who pay for monthly subscriptions that they don't have. Check your understanding problem. It should go pretty quickly, and then hit play when When you're done, we'll go through our answers. Okay, so in this Check Your Understanding, we're talking about adults who pay for monthly subscriptions that they don't actually end up using. And we're given a 95% confidence interval for the proportion of adults who pay for subscriptions they don't use. And we're told that is between 0.352 to 0.548. So first we're asked to interpret. So I used my sentence template from up above. We're told 95% confident. So we are 95% confident that the interval from 0.352 to 0.548 captures the true what? Well, here's a trick for this is you can always look back at the problem and you'll see here it says a 95% interval for proportion of adults who pay for subscriptions they do not use. So that's what I filled in here. So it is, I like to say the true proportion of adults who pay for subscriptions they do not use. So I fill in my percentage, my interval, and then my parameter in context. All right, then in part B, we're asked to figure out what had been the point estimate and margin of error if this was our interval. So point estimate, I found the middle of that interval, which is 0.45. Margin of error, I found the width, and then cut it in half, and I got 0.098. And then in part C, we're going to make a decision. So we are told that there's this reporter who claims that a majority of adults continue to pay for monthly subscriptions they do not use. So first I want to think about what does it mean to be the majority of adults? Well, what that means is that it has to be above 50% to be the majority. So this reporter is saying, well, above 50% of adults pay for monthly subscriptions they do not use. And let's look at our interval again. Well, our interval does contain values above 50%, so that is plausible. However, is it also plausible that maybe we don't have the majority of adults, meaning are there any values below 50%? Well, yes, there are. So because our interval contains values that are both above and below the 50%, we can't say for sure that the majority of adults pay for subscriptions they don't use because it could be below that. So in this case, the decision I made is, well, I can't support this claim, or in other words, we do not have convincing evidence to support this claim. It is plausible that actually below 50% or less than the majority have subscriptions they don't use.